Welcome back to Pre-Algebra with Miss Betsy. Today we are discussing rate, and we see that rate is simply a ratio that compares two different units. If you're tracking along with me, you know that I am using Pre-Algebra for Christian Schools. It's published by Bob Jones University Press. I'm using the first edition. Our brief lecture today is from section 9.3, Rate, and we are on page 288. There's really like nothing for me to show you on this, so this may be the world's shortest video ever if I can keep my rabbit trails to a minimum. Okay, rate is a ratio that compares different units. Rate in miles per gallons, feet per second, miles an hour. These are examples of rates. So we have our problem here. It tells us that the 8th grade class traveled 162 miles in 3 hours on their fall field trip. What was the rate of travel in miles per hour? Ratio compares two different units. So they're asking rate is a ratio that compares two different units. So what two different units are being compared in our problem here? Well, miles per hour. Miles per hour. So this is their rate in miles per hour, which it's a ratio. We're comparing two different units. What are the units which we are comparing? First unit is miles. Second unit is hours. In other words, how many miles can you go for every hour that you travel, hour that you drive? And we have speed limits are in miles per hour. 60 miles per hour, if you're out on the highway going, you don't stop, you keep your cruise control on, or you keep your needle pegged at 60 miles an hour at 60, or your digital display at 60. You go for an hour. If everything's calibrated correctly, how far have you traveled? Well, you've traveled 60 miles. So that's an example of a rate. Our problem tells us that the class traveled 162 miles in 3 hours. So what is the rate? 162 miles in 3 hours. Do we care that they traveled 162 miles over 3 hours? No, they want to know how far did they travel in 1 hour. And this is theoretically, if they kept the same speed, didn't stop, what was their average rate in miles per hour? Do we have a common factor here? Greatest common factor of 162 and 3 is 3. We can say 162 divided by 3, 3 divided by 3. And we have, when you do that, is it 57? No, it's 54 miles an hour. 54 miles in 1 hour. Okay? 162 divided by 3 is 54. 3 divided by 3 is 1. So we have 52 miles divided by 1 hour. Our rate is 54 miles per hour. This is all we're talking about. A rate is a ratio that compares two different units. Miles per hour, we are accustomed to using the abbreviation MPH. 24 miles per 1 hour here. This is just another way of expressing that same quantity. This is all that we're talking about is rate. It's that same fractional look to it. It's just instead of numbers, you actually are comparing units. So let's look at our second problem here, and we're going to use proportion to solve a word problem that involves this rate. So what's rate? Rate is a ratio that compares two different units. And what is proportion? Well, proportion is an equation that tells us that two ratios are equal. So let's see what we have. Write a proportion and solve. An athlete's resting heart beats 112 times in 2 minutes. How many times does his heart beat in 5 minutes? We'll take this a bite at a time. We're talking about a heart rate. What relationship is there that we're looking at here with this heart rate? Well, it says beats per, which is in division bar, beats per minute. This is our rate because it's a ratio comparing different units. Number of beats, time in minutes. Now this is a guy or a girl who's in good shape and their resting heart beats 112 times, 112 beats for how many minutes? In 2 minutes. This is our first ratio. The relationship between two different quantities happens to be a rate. Now, what do we want to find? It says, how many times does his heart beat? Well, it is a guy. How many times does his heart beat in 5 minutes? So we don't know what his beats per minute is. Let x equal the beats per minute. Actually, the number of beats of his heart. We want to know how many times does his heart beat in 5 minutes. This is a proportion because we're setting up two equal ratios. We can cross multiply. And we know that in a proportion our cross products are equal, so we're going to have 112 times 5 is equal to 2 times x. Because we have an equal sign, we can look at the equation this way. We can look at the equation backwards. So it doesn't matter which one comes first. 2x, 2 times x is equal to 5 times 112. 2 times x is equal to 5 times 112 would be 560. What are we going to do now to solve this? We're going to divide both sides of this equation by 2. And when we do that, we see that the number of beats that this athlete's heart pumps, and the number of beats in 5 minutes is 288 beats in 5 minutes. And you would want to write every bit of this information here, because not only do we want to know 280 beats, we want to know what period of time elapsed during which that heart was beating 280 times. 280 beats in 1 minute, you would be nearly dead. If I don't know if a human heart could sustain that rapid of a beat, even the beat of an unborn baby. Baby's heart is not anywhere near 280. So anyway, this athlete, in 5 minutes, his heart beats 280 times. That's all we're talking about here for rate. I'll see you next time.